In ancient Greece, a mathematician philosopher named Euclid depicted and explained the three spatial dimensions we are now so familiar with and which are taught to nearly every school child in the world. A point represents zero dimension in space, and when you move it, it becomes a line, the first spatial dimension. Move the line perpendicular to itself, and it becomes a plane, the second dimension. Move the plane perpendicular to itself, and it becomes a solid, the third dimension. Another way to represent the idea of Euclidean spatial dimensions is to rotate the line around its center to make a circular plane. Spin the circular plane around any axis or diameter, and it makes a solid sphere. In the 19th century, another mathematician named Bernhard Riemann derived from working with spheres a version of space that is already curved. In Riemann's geometry of curved space, the shortest distance between 2 points is an arc. One practical application of this idea is the geodesic, used to map the path of airplanes flying from one point on the surface of the Earth to another. In Riemann's version of space, the originating point travels in a curved path. Since this is just a principle and not an object, we can show the arc being formed with any radius of curvature. The first dimension of curved space is derived by a moving point which traces a circle. It is just the outline of a circle, a curved line that meets itself but encloses nothing. The second dimension of curved space is derived the same way as the circle, by rotating the circle around any point on it, and that motion forms a toroid. Our normal Euclidean way of regarding an image like this is to regard it as a solid, but it is only the surface of the toroid we are viewing, a surface that is completely curved around itself, and like the circle it is derived from, it encloses nothing. And it is not a static surface, as in Euclid's geometry, but a moving surface which continuously converges on and diverges from its center point. To better understand the implications of a totally curved surface in the form of a toroid and its principle of moving circular convergence, let's apply it to a practical idea. A classic paradox in physics is, light behaves like a particle when it is traveling, but when it interacts with other fields, it behaves like a wave. What could the internal substructure, the architecture of a photon be that would manifest accordingly? A rolling toroid traveling through space. Following any one point on the surface of the rolling traveling toroid, the combined actions of rolling through itself plus its trajectory leaves a trace like a seismograph tracing a sine wave. If we were to follow not just one point on its surface, but a whole latitude of points, the trailing trace would look like a waving, pulsing tunnel. In reality, there is neither a point nor a latitude to follow. The whole surface of the toroid is rolling while it is traveling, so the trailing trace, so to say, of those two motions would appear in an animation as a solid cylinder with no discernible oscillations. But by depicting the sinusoidal path of one point, or several points on one circulating latitude, it helps us to understand why the toroid acts like a wave when it interacts with other similar fields. Thus, the rolling, traveling toroid behaves the way we know photons behave. All photon toroids have a frequency and a wavelength, just like any wave. And as a quantum, as a unit of energy, it has an amplitude of 1. The frequency and wavelength vary according to the difference between the rates of its rolling motion and its travel. since its rate of travel is constant, the speed of light. Only the frequency and wavelength can vary, and depending on how fast the frequency, that determines where it is on the spectrum of radiant energy, whether it is a low-energy radio wave, a mid-range energy of infrared and visible light, or the high-energy waves of X-rays, gamma rays, and cosmic rays. The photon toroids of high-energy rays spin around themselves so fast they resemble hardness, giving us the impression that the rays are composed of some mysterious, irresolvable particle. An easy analogy is how musical tones are generated. At first we hear a rhythmic pattern, a steady beat. Then the beats speed up, the frequency between beats gets faster and faster, until the beats blend together perceptually until we perceive a smooth tone. We no longer hear the beats that the smooth tone consists of, but they are there just the same. The third dimension of curved space is made the same way as the toroid, by rotating the toroid around its own center point to form a hypertoroid. Since all the dimensions of curved space are formed by the circular movement of the preceding dimension, there is no need to add a fourth dimension in the form of time. Everything is already in circular motion, with all the points in space moving in circular paths in an endless rolling now.